All right, so I'm just going to sort of shoot around and go through these problems in 2.4. And that was dealing with the algebra of functions. All right, y'all, so this one we're going to let f of x equal x squared minus 8. G of x is going to equal 2 minus x. Oh, hang on, let me get my, I got to share my screen with you. I'll make it a little better. So y'all should be able to see my screen now where I'm writing. So f of x was x squared minus 8. G of x is 2 minus x. They want us to find f times g of a. So they're wanting me to multiply these functions, and they also want me to put an a in for those x's. So here we go. We got f times g of a. So I'm going to put my functions in parentheses and use that for my multiplication. So I'm going to put in f, which is x squared minus 8. But remember, they're telling me to put an a in for the x. So that's actually going to be a squared minus 8. So you got to put that function in and then put in the variable that they're giving you, or numbers. Sometimes those are numbers also. And then we got 2 minus x. Well, that's going to be 2 minus a. So the main thing was just replacing those x's with the a, since that's what they put in my parentheses here. And then I'm just going to FOIL that. So, FOILing, since I'm multiplying, if you want to put an exponent by this a at the end, you would put a 1 there. All right, so here we go. We got an a squared times 2. That'll give you a 2a squared. Then I want to multiply a squared times that negative a. That'll give me a negative a to the third. So that I just did, hold on, I got to kick someone off on mute. All right, I think we're better now. All right, so I did the a squared times 2, a squared times a negative a. Now I'm going to multiply negative 8 times the 2. That'll give me a negative 16. And then the negative a, negative 8 times the negative a gives me a positive 8a. So the only thing you could do at this point would be add like terms, but I have no like terms. So the only thing that I will do that they might request you to do is put these in descending order. And that means from the highest exponents down to the lowest. So if I was putting it in descending order, I would get a negative a to the third plus my 2a squared. So I'm just rearranging it, plus my 8a, and then minus my 16. And this one actually did tell me on the answer blank, it said, type it in descending order. So this here is your descending order. Okay, so that's one of the main things you got to watch out for, is how they want that answer written, okay? All right, let's see here. I'm going to do a couple subtractions now. So this one, we're going to let f of x equal negative 2x plus 2. I'm going to let g of x equal x squared minus 3. They want me to find g minus f of x. So the thing they're doing on this one to be tricky is they're reversing the order of what they're asking for. Most of the time it was f minus g, so they're just trying to be tricky and throw it in the other order on you. So we know g minus f of x is going to equal my g minus my f. And if you notice, this time they didn't give me no numbers to plug in or no variables to plug into it. So we're just going to put the functions in where they go. So it's g minus f, so I'm going to put g in first, which is the x squared minus 3. And then my f of x was a negative 2x plus 2. All right, so we got our g minus our f. Next thing we're going to do is remove the parentheses. So there's nothing in front of the first parentheses, so you can bring out that x squared minus 3. Second parentheses follows subtraction. Anytime you got parentheses that follow subtraction, you got to treat that negative like a -1 and distribute to everything inside the parentheses. So right here you have a negative times a negative 2x. That's going to make that a positive 2x. You now have this negative times this positive 2. Unlike signs, is going to make that a negative 2. So now I'm at the point where I can only add like terms. So the x squared has nothing to add to, so I'm going to bring down my x squared. And I'm going to put it in descending order. So next I'm going to put the positive 2x. The x has nothing to add to. But here, on my numbers, I do have like terms. I got a negative 3 and a negative 2. That'll make that a negative 5. And y'all, at that point, nothing else is like terms, so we are done. So really, to me, the trick on these is figuring out what are they asking for and getting it wrote correctly at that point. And if they're giving you variables or numbers to put in for those x's, you want to get them put in on that first step there, okay? Now, this one's going to be subtraction, and I'm going to have a number to plug in. So here we got our f of x is going to equal x squared minus 3. G of x will equal 8 minus x. We're going to find f minus g of a 4. All right, so f is first, so I'm going to put my f in the first parentheses minus my g in the second parentheses. Now remember, this time they are giving me a 4 for my x's, so when I plug these in, I'm going to replace the x's on both of these with a 4. So the first one would give me a 4 squared minus 3. The second parentheses, I would have an 8 minus 4. So y'all, when they give you a number to plug in for your variables, you will have no variables in that expression when you're working it. All right, so the first parentheses, I'm going to work inside each parentheses first. So the first parentheses, I would hit the exponent first. So that gives me a 4 times 4, which is 16, minus my 3. That's going to be minus my second parentheses. And I can work that. 8 minus 4 gives me a 4. All right, so the only thing I can do now is the first parentheses. I can still work in it. So I got a 16 minus 3, which will give me a 13. And then I'll bring down my minus 4. All right, so we've done everything in both the parentheses. Last step is actually subtract. In 13 minus 4. Oh, what's that going to give us? About a 9. Okay, so if you notice, when it gave me replacements that were variables, I couldn't get rid of them variables, and I had pretty long answers. Same thing on this, and they didn't give me a number. So I still had sort of a fairly long answer. But when I do give you a number, that's going to simplify all the way down to a single number for those answers. All right, so any questions on that, y'all? If not, we'll get into some domain type questions. All right, so y'all look all right on that. So let me refresh y'all a little bit on the domain.
Can you hear me?
Yeah.
I'm trying to record, but it says I have to ask you permission to record.
Okay, I'm recording it, but let me see.
Okay.
I'm recording it, so
If you're recording it, I can just.
Yeah, I'm recording it, so I'll send y'all the actual video of it. And then next time I'll remember.
Okay.
I think there is a place where I can click for y'all to do that too, so we'll do that next time.
Yes, sir. Okay.
So y'all on these domains, the only thing we're worried about in our functions as far as domains go, the first question you got to ask yourself, is the function a fraction? Okay? Because that's the only thing we're worried about at this point in this class, is the function a fraction. If it's not a fraction, then it's going to be good for all real numbers. So if no fractions, your domain would be x such that x is a real number. Because if there's no fractions, I don't have to worry about denominators equaling 0. And if it's not a fraction, any number I throw in, it gives me out a number. It's just those fractions you got to worry about. But remember, if it is a fraction, so if it is a fraction, what we had to do was set the denominator equal to 0, solve for the variable, and then we exclude any solutions from our domain. Okay, so if it makes a fraction undefined, we got to kick those x values out of our domain since we didn't get a real answer for those, okay? So these problems are just designed to see if y'all are getting the idea of our domain down. So they're giving me f of x is going to equal x squared. G of x is going to equal 2x minus 7. They want to find the domain of the sum difference product and quotient of f of x and g of x. So basically, this is 4 problems in one because I got to do the sum, the difference, the product, and the quotient. Now, I don't have to simplify these or work them. I just got to find the domain. So let me start with the sum. The sum will be f plus g of x. That's going to equal my f plus my g. Well, f was an x squared. G was the 2x minus 7. Now, I'm just going to set them up like that because all they want me to do is find a domain. So, I got two functions sitting here, an x squared and a 2x minus 7. Question number 1 says, is the function a fraction? Well, y'all, I don't see no fractions here. Y'all shouldn't see no fractions either, right? So the domain of that automatically will be x is a real number. Because y'all, guess what? I can put any number in for that x and square it, and I still get a number. I can put any number in for that x, multiply and subtract 7, so I'm not being restricted by anything on that one. Let's look at f minus g of x. F minus g of x will be my f minus my g. Well, my f is still x squared I'm putting in. My g is still going to be the 2x minus 7. So really, other than this one's subtraction and this one's addition, they're set up exactly the same. So I'm going to ask myself that question again. Is the function a fraction? And y'all, once again, neither one of these functions have fractions in them. So my domain is going to be x such that x is a real number. All right, so on this one, what was next? They said product, which is multiplication. So f times g of x will equal my f times my g. F was x squared. G was a 2x minus 7. So although I'm multiplying this, the main thing I'm looking for is the function a fraction. And y'all, there is no way there's any fractions on this. So once again, since I have no fractions, the domain is x such that x is a real number.
So whenever we answer that homework, we just write or we just put x is a real number. That's all we have to put.
Can you see what I'm putting on there right now, this page? Do y'all see the page?
Yes.
Look at these answers for B. X such that x is a real number.
Oh, okay.
So they'll usually give you that answer as one of them. But let me pull this down a little bit. So y'all watch this division, because division will be a little bit different on this. So yeah, they give y'all all the fancy parentheses usually, and they'll usually write the x is a real number part. And then if they do have a number you got to worry about, they'll write it all, and then they'll say and then you put the number in. So division is going to be my f divided by my g. So my f was an x squared on top. My g is a 2x minus 7. Well, guess what? If you ask yourself, is the function a fraction? This one is definitely a fraction. So since this one's a fraction, you got to take that bottom and set 2x minus 7 equal to 0. Or you can use that not equal symbol I was showing y'all, because it can't equal 0, but I set it to 0 to find those numbers. So we're going to solve this. I'll start out by adding 7 to both sides. So by adding 7, I got the 2x by itself. Now I need to turn the 2x into a 1x. So I divide both sides by 2. And if you notice, that's going to give me x equals a 7 over 2 that I cannot realize, simplify. So on that one, your domain would be x such that x is a real number. And now, MATLAB gives you this much of the answer. All we got to do is put in what we got from our equation, okay? And since we got negative 7 halves over here, in here you got to put x cannot equal 7 halves. You solve for it over here, but remember, we said we have to exclude any solutions from that. And to exclude a solution, you have to use the not equals on that, okay? So, on these, I set them up and I look how they're going to look in the beginning, and then I determine whether I got a fraction or not. If I do have a fraction, I got to take that denominator, set it equal to 0, so I can find those numbers. So I'm going to do another one of these. These are pretty interesting. So let's go to my next example. I'm going to have f of x equals 1 divided by x minus 4. G of x is going to equal 6x to the third.
Can you move the paper down a little bit? Sorry,
Oh,
I can't see
yeah.
the.
It's my camera. I was moving it down a while ago, so I had to move it back up. All right, so y'all with me? I got a f of x is 1 over x minus 4. And then my g of x is 6x to the third. All right, I'm going to find the domain of everything again. So find domain of f plus g of x, f minus g of x, f times g of x, and then I'll even do f divided by g of x. Now, I'll tell you the truth. Some of these, they don't ask for this division on them, but I'm doing it just to give y'all more practice, because on 1 or 2, they will ask for that quotient, okay? So I want y'all to make sure you can set these up right. So I'm going to do the adding first. F plus g of x is going to equal my f plus my g. And if you notice, every one I start out with just throwing me some parentheses first. And then I put in my f, which was 1 over x minus 4. And my g was a 6x to the third. Well, y'all guess what? When I ask myself if I see a fraction, yeah, I see a fraction in the first part of this, right? I got 1 divided by x minus 4. So that's bugging me. Now, this one over here has no fractions, so I'm not worried about it. So to find my domain, I got to take the part that was a fraction and take that x minus 4 and set that equal to 0. Now, since that's the only fraction, once I solve this, I will add 4 to both sides. And I get x equals a positive 4. So that domain will actually be x such that x is a real number and x cannot equal that 4. Okay, so that's all this domain stuff is you're just telling me if there's any numbers that won't work when you plug them into these expressions, okay? So y'all, what's next? We got f minus g will equal my f minus my g. So I got 1 over x minus 4, which is my f, and then my 6x to the third is my g. So, y'all, it looks like the only thing I'm worried about again is this x minus 4 on the bottom of that fraction. So once again, you would set that equal to 0, but I've already worked it up here, so technically you wouldn't have to work this again, because you know that if you solve it, you're still going to get a 4, which means the domain is still going to be the same. X is a real number, and x cannot equal that 4. I'm going to start noticing something after I do this f times g of x. So f times g will be my f times my g. F, once again, was 1 over x minus 4. G was 6x to the third. And y'all, it looks like for the third time in a row, the only thing bugging me is that fraction with the x minus 4 in the bottom. So technically, you would be setting that equal to 0 again, adding your 4, so that we get an x equals 4, which means for the third time, I get the same domain. X is a real number, and x cannot equal that 4. So if you've been noticing the last problem I just did and this problem, are we not always getting the same answers for the adding, subtracting, and multiplying on these? While ago, they all was good for all real numbers. Now those 3 are all good for every number but 4. So you'll notice little patterns
So
like
we don't do anything.
Again?
So we don't do anything with the g of x.
Oh, because it didn't have a fraction. So unless it was a fraction, you're just
Okay.
leaving it alone. Because anything I throw into these x's, I can cube them and then multiply by 6. To where here, the reason I'm worried about that fraction, because if I put a 4 into that, I get a 1 over 0. And remember, 1 over 0 is undefined. Okay? Now, let's see what happens on this f divided by g. F on top divided by my g. So let's see, my f was 1 over x minus 4. My g was a 6x to the third. So this gives me what I call a complex fraction. A complex fraction is a fraction within a fraction. So I'll tell you, the first thing that bugs me is that fraction on the top. That fraction on the top has a denominator. So what I need to do to that is set that x minus 4 equal to 0. Solve that by adding 4. So I automatically know that the x cannot be 4 because of this fraction. But check this out. Once you put a number into this on the top, you then got to worry about this big fraction because it has a denominator of a 6x to the third. So technically, you got to worry about this part of the fraction now. So you would set 6x to the third equal to 0 and solve that. So y'all, I'll tell you to solve this. First thing I would do is divide by that 6. So I get x to the third equals 0. And then to undo exponents like this, you take a cube root. So cube roots undo x to the thirds. So these 3's would cancel. You get your x. But y'all, the cube root of 0 is going to be a big O 0. So check this out. I couldn't be a 4 because of that top fraction. I can't be a 0 because of the main big fraction. So I had 2 places I was worried about. So when we write this one down, I'm going to just scoot that down for a second. You would have to write x such that x is a real number and x is not equal to 0, 4. So 2 numbers would make this thing undefined, okay? It's because I put a 4 here, or if I put a 0 in the bottom. So have you noticed on both of these big problems I did, adding, subtracting, multiplying all had the same domains. It was the division that always has the different domain, okay? All righty, y'all. So that looks like most of that 2.4 stuff. So what I would ask, is there anything that's bugging y'all as far as problems that y'all need any help on? So come next week, Monday, we'll start getting into 9.1 material. 9.2, it's still doing the same type of algebra type stuff. So it's not going to be too bad. And most of these, what I've been seeing in the homework, y'all been getting. So what I'll do, I'm going to stop recording.